today's maths class, and today we'll do symmetry. Our learning objectives are reflection symmetry, demonstrations of reflection symmetry, line of symmetry, asymmetric objects, rotational symmetry, figures having line symmetry and rotational symmetry. In our everyday life, symmetry is quite a common term. When something is evenly balanced, we say it is symmetrical. Symmetry occurs in many areas of mathematics. The Taj Mahal and the Lotus Temple. Lotus Temple look beautiful because of its symmetry. So here you can see Taj Mahal and Lotus Temple. These are symmetrical. So suppose this is the line of symmetry that will divide the given figure into two equal halves. This lesson explains symmetry in maths and explore the basic type of symmetry. So first is reflection symmetry. Reflection symmetry means the exact match in the size and shape between two halves of something, as if one half reflects in the mirror. For example, draw a line segment AB and its perpendicular bisector PQ, bisecting it at O. Suppose this is a line segment AB. Now we have drawn a perpendicular bisector which will divide the given figure or line segment into two equal halves. So AO equals to OB. Clear? The two halves AO and OB of the line segment match exactly in size and shape. They are having reflecting symmetry. If the mirror is placed along the dotted perpendicular bisector facing any half, the other half will be reflected in the mirror, giving the complete view of the line segment. Similarly, an isosceles triangle, capital letter A and a square and a rectangle, a mask, a circle, a spoon and envelope are the examples of the reflection symmetry. Suppose we have placed a mirror along this dotted line. So we can see the other half of this line segment that will complete it, the line segment AB, that is equal to the same size and shape equals to AO. So this is called the reflection symmetry. Some of these objects have been divided into two halves by a dotted line in the figure. If you place a mirror along the dotted line, any object, you will have its complete view. Agar you will place a mirror along the dotted line, so you will able to see the complete view of that object. Like here in figure, this is an isosceles triangle. So this is the line of symmetry. These are exactly same in size and shape. So if we place the mirror along this line, we can see the complete view of this object. For capital letter A, this is the line of symmetry. Square, rectangle, this mask, circle, spoon and envelope. So these are the line of symmetry or reflection symmetry for these given figure. Next is demonstration of reflection symmetry. For this, we'll do an activity below given half of few objects. Place a mirror along the dotted line of each the object and then observe whether you have its complete view or not. Write yes or no against each picture. So first, if we place the mirror along this dotted line, we'll get the complete view of given figure like this. So observe whether they have the complete view or not. In first figure, they will have the complete view. So we'll take it like this. We have to check for other objects also. Next is line of symmetry. A line which divides the object between two halves which exactly match in size and shape is called the line of symmetry. Each of the objects shown in the figure has been divided into two exact halves by a dotted line. The dotted line is called the line of symmetry. An object may have one line of symmetry, two lines of symmetry or many lines of symmetry. For example, the capital letter A that have one line of symmetry. Next, H, it has two lines of symmetry, vertical and horizontal, two lines of symmetry. In a circle, it has many lines of symmetry. Next is activity 2. Demonstration of line of symmetry. One line of symmetry, fold the piece of paper, cut a shape from the folded edge. This cut out shape as shown below is the symmetrical. Like this, we will fold the paper and cut the shape like this. When we open it, it will seem something like this, and this is the line of symmetry that divide the given figure into two equal halves. Next, two line of symmetry. Now what we'll do? We'll fold the piece of paper in half, then in half again, 2 times. Cut the shape from the corner as shown, like this. When we'll open it, the figure or the shape will look something like this. It have two lines of symmetry. This vertical line and this horizontal line. Two lines of symmetry. Next is exercise 17.1. Draw at least two lines of symmetry for each of the following figure. So in this figure, we can draw like this. One line of symmetry and another this line of symmetry. That will divide the given figure into two equal halves. Clear? Next is asymmetrical objects. The objects which lack symmetry are called asymmetrical objects. The part of the feature do not corresponding to each other in size, shape, etc. In activity 1, object number 4 and 6 are asymmetrical objects. Asymmetrical objects have no line of symmetry. Other examples of such objects are the capital letter J and the number 7, a plant and a right angle. They have no line of symmetry or they are symmetrical objects. Like here, J, 7, this plant and this right angle triangle. They will not show any line of symmetry, so they are symmetrical figures. Next is rotational symmetry. A figure is said to have the rotational symmetry if it's fit onto itself more than once during the complete rotation. Let's study the following illustrations to understand the rotational symmetry. Take the letter capital H. This is the original position. Now we will rotate it 90 degree to the left to right. So it will look something like this. Again we will rotate the position 90 degree. It will look something like this. Same like the original position. So capital letter H fits onto itself when rotated to 180 degree naturally. It will again fit onto itself when rotate 360 degree as well. Again if we will rotate, it will look something like this, and then again we will rotate, it will look something like its original position. So 2 times it fits into original position, 180 degree and 360 degree. Clear? So it will again fit onto itself when rotate 360 degree as well. Hence it shall fit onto itself 2 times during the complete rotation. So complete rotation में original position पे कितनी time? 2 times fit होगा. 180 degree पे rotate करने पे and the complete rotation 360 degree. Take equilateral PQR triangle. So this is the equilateral triangle. All 3 sides are equal. So this is the original position. Now we'll rotate 120 degree. Then 240 degree and 360 degree. So it will look exactly same as its original position. The above given figure will help you to understand that an equilateral triangle when rotate 120 degree, 240 degree and 360 degree attain the original position. It means it fits onto its 3 times during a complete rotation. Take a square ABCD. This is a square ABCD. This is the original position. Now we'll rotate 90 degree, then 180 degree, 270 degree and 360 degree. So 4 times it look like its original position. So it have 4 line of rotational symmetry. The given figure will help you understand that the square when rotate 90 degree, 180 degree, 270 degree and 360 degree attain the original position. It means it fit into itself 4 times during the complete rotation. Next is order of rotational symmetry. The number of times the figure fit onto itself during one complete rotation is called the order of rotational symmetry. Means during a complete rotation how many times it fit into its original position. That is known as the order of rotational symmetry. In the given illustration, capital letter H has the rotational symmetry of order 2, the equilateral triangle has the rotational symmetry of order 3 and the square has that of 4. Next is exercise 17.2. Write the order of rotational symmetry in the following figure. In first one, it have order 2 rotational symmetry. Rotational symmetry का order हो जाएगा because 2 times it will fit into original position during the complete rotation. 360 degree rotate करेंगे, so 2 times it will fit into original position. So order of rotational symmetry will be 2. Practice all the questions of this exercise. Next is figure having the line symmetry and rotational symmetry. On the basis of our discussion, we can say some figures have the line symmetry as well as the rotational symmetry. For example, the letter capital H has 2 line of symmetry and the rotational symmetry order 2. So letter H में line of symmetry भी होती है and rotational symmetry भी होती है. Other example of the figure having the line of symmetry and rotational symmetry are: a square has 4 line of symmetry and rotational symmetry of order 4. A rectangle has 2 line of symmetry and the rotational symmetry of order 2 when rotate 180 degree and 360 degree. An equilateral triangle has 3 line of symmetry, namely the bisector of its interior angle as well as the rotational symmetry of order 3. Look at the adjoining figure. It has 4 line of symmetry, the dotted one, and the rotational symmetry of order 4 when rotated 90 degree, 180 degree, 270 degree and 360 degree. In this figure, it has 4 line of symmetry. This is the line of symmetry 1, 2, 3 and 4, and it has rotational symmetry of order 4 when rotate 90 degree, 180 degree, 270 degree and 360 degree. As the rule, each regular polygon has a line of symmetry and rotational symmetry of various order depending upon the number of sides of the polygon has. For example, the regular pentagon have 5 line of symmetry and the rotational symmetry of order 5. Next is exercise 17.3. What do you mean by the order of rotational symmetry? So, the meaning of order of rotational symmetry, the figure fit into its original position. How many times a figure fit into its original position during the complete rotation? That is known as the order of rotational symmetry. So, practice all the questions of this exercise. Next is, let's recall. Multiple choice questions. Take the correct options. Which of the following does not have the line of symmetry? So, figure C, it does not have the line of symmetry. So, C is the correct option here. So, here we end the chapter. I hope you understand it well. Now, you have to practice it.